Hi everyone, today I'll be going through P6 prelim science paper, Catholic high school paper over here. So this is 2024. So a magnet was placed on an electronic balance as shown in diagram 1. So they should have recorded some mass, but we are not sure about the mass of the magnet being measured. Okay, so the reading on the electronic balance change when another magnet or iron bar is held close to the first magnet. So they say they put a magnet and a magnetic and an iron bar, which is a magnetic material. Okay, so if you take a look at this for diagram 2, can you see that the light poles are facing each other? So they will more or less repel each other. Okay, they will repel each other. Okay, so they will push away from each other. So when they push away from each other, what happened? This actually exerts a push force onto the weighing scale. The reading should be higher than its mass. Okay, the reading will be higher than its mass in this case. So that means without the one in diagram 1 without magnet, right? Without magnet, the mass recorded should be lower. Mass is lower than 137 gram. Okay, it should be lower than 137 gram. Okay, so in this case, right, if you take a look at diagram 1, which one is lower than 137? Okay, it will be 1 and 2. Okay, 1 and 2. So this one is wrong. So you take a look at diagram 3. Diagram 3 show you an iron bar. So what happened is that, okay, when you have a iron bar over here, they will attract each other. Okay, when they attract each other, right, can you see it kind of lifted it up to some degree? So it's going up a little bit, but the gravitational force is still pulling it down. So in essence, the gravitational force is pulling it down, but is pulling it less downwards because there is a upward attraction force towards the iron bar. So over here, the reading over here will be way lesser than 137 as well. Okay, will be lesser than 137, less than 137 gram. Okay, because the magnet, right, will now press, okay, or rather will push less into the weighing scale, so it will record less than 137 gram. Okay, so the highest number in this case will be diagram 2 because it pushed into the weighing scale. So with that, the correct answer should be 2 in this case. Okay, the correct answer will be 2. So so over here I have actually recorded a video to see how the magnet will react on the weighing scale. Okay, when you have number 1 magnet, which could have been repulsion or attraction, and number 2 will be magnetic material, and number 3 will be non-magnetic material. So if we were to go through this, right, if you put another magnet that is repelling, right, the reading will be higher. Okay, it will be higher than its original mass. So if there's attraction there, it will be lower than its original mass. Likewise, if you put a magnetic material, the reading of the mass of the magnet will be lower because it's attracting. Okay, so this one no change because there's no reaction. Okay, so I'm going to show you a video in a while. Hey everyone, so today we have an experiment over here. We have a magnet, we have another bar magnet, magnetic material, and a non-magnetic material. So this is a magnetic material, so it attracts to the magnet. So what we're going to do, we're going to test this with a weighing scale. So what will happen here is that I'll put a magnet on the weighing scale. So over here, the blue color, which is the south pole, is facing upwards. So what I'm going to do is that I'm going to put the 2 light poles together and then see what happened to the weighing scale. So now the mass of the magnet is about 18.2 or 0.1 gram. So I'm going to put it very, very close. So you can see that when I put it very, very close, the light poles are facing each other. The mass, the reading recorded actually increases. Okay, the reading recorded actually increases. Why? Because over here, right, they are repelling each other. And then because there's no space for the ring magnet to move, it will actually push down into the weighing scale, causing it to record more mass. Okay, so over here, as I push it nearer and nearer and nearer, so more mass is being recorded. Okay, so what happens if I do the reverse? I put the unlike poles together, so they will attract, right? They will tend to attract. So when they tend to attract, the reading become lower and lower. Because the original reading is 18. So when I put it near, okay, when I put it near, okay, the reading become 9 or 10. So the reading actually reduces. Okay, so now what happens if I put a magnetic material? So it will be attracted, right? So the reading will therefore decrease again. Let's take a look. Okay, so can you see that the reading actually decreases? Because why? It actually pushed less into the weighing scale because it wanted to be attracted up towards the magnetic material. Okay, that's why it will push less. Reading recorded will be way lesser. So now if we have a last material, which is the non-magnetic material, this is the copper plate. I put it near here or near here. There's actually no change in the reading, no change in the reading at all. Because why? The magnetic material is not attracted to the magnet, so it will not cause any differences in the in the reading recorded. So with that, let us recap again. So if we put the light poles together, the reading increased. We put the unlike poles together, the reading decreased, because it pushed less into the weighing scale. Likewise for the magnetic material, because it is being attracted to the magnet, the reading will decrease. The non-magnetic material, the reading will reflect no change. So with that, thank you very much.